All right, everything looks good. Let's see if we can. Oh, there it is. Opinion is weird. Thanks for the follow. Much appreciated. Can we hear? Yeah. All right. That looks good. That alert though is loud. Not bad though. All right. Okay. Let me check that. Okay. That's what I'm assuming. Maybe I don't need to be in the public lobby at all. Maybe it just shows up on my Discord. I don't know. I guess something new to find out. All right. Anyways, get to work. So, I definitely have plenty to fill up an hour plus. So we'll just get started, and if people stop me, we will figure that out when it comes. So when I look at this function, we are looking at f of x equals e to the tangent squared x. I know it's a little fuzzy, but let me clean it up. So what I'm going to utilize is u substitution. So I'm going to put tangent squared x as my u, and then take the derivative of that and get 2 tangent x, because I have to do the power rule. And remember, outside times the nested function. And then we're going to times it by the derivative of the nested function, which is tangent. Okay, so then that's going to give us secant squared x. And then we could even times it by the other nested function, but the derivative of x is just 1, and that's not going to change anything. Okay, so when we look at this, we have f of x equals e to the u. So when I take the derivative of that, I guess if we want to be proper with this, let's do it properly. We're doing f of u now instead. So we're going to take the derivative of u. So e to the u is just going to be e to the u times du. So then once we do that, we're just going to substitute in our u back into our u and our du back into our du. And when we do that, lick a little glove that helps me slide over it. Once we do that, we'll be good to go. So I'm going to have f prime of x, because we're going to put x back in, e to the u, which is tangent squared x times du. Well, du is 2 tangent x secant squared x. And this whole long answer is what the solution actually is. They might put e to the power at the end of it as opposed to the front of it. So it could look like this. And the only reason they would do that is so that you don't confuse what the exponent is on e with the rest of the problem. So it might look like that. That's what I would assume would be the best looking property of it. But yeah, so that's utilizing u substitution. And also, if you are in Discord, don't be afraid to pop up, ask questions. I know you guys love to do that. You people love to do that. If you have some. Hey, there we go. Excellent. Thanks for coming in. But yeah, pop in, ask questions if you need to. All right. So next one we have going is this one. And this one we really need to restate this one big time, because this actually is not a limit problem. Do we remember back in the day the limit as h approaches 0? We have f to the a minus h minus f of a over h is really just trying to do this. At the end of the day, that's what it's trying to do. Actually, we can do this. Set it equal to this. So we have that limit of, you can see a function. There's a and a h embedded. And then it's subtracting by just the f of a. And then all over h. So the first thing that we want to kind of focus on is, what is our function? Remember we talked about this, and what is the a value they want us to plug in? So if we think about f of a, this one right here is probably the easiest to pull from. So let's start that actually. Let's do f of a. And f of a in this is e to the negative 1. So if we were to substitute a value in, what will we be substituting in? And if we think about a minus h, and we think about a, hopefully that you can come to that conclusion that a is negative 1. And if we looked at just f of x instead of a, actually, why don't we take a step? Well, you know I like to crawl. Couldn't we look at it like that? If we did f to the negative 1 value, we would get e to the negative 1. If that's the case, then what is x? It's that. So then, if I have this function, then the question, or the next part of it is, what is the derivative with respect to x? And hopefully we know e to the x ln of e. However, those won out, so that they really don't exist. Oh, they do, but they just won out. And we're just left with e to the x. Doesn't make much of a difference when it's e to the x, but if we had 2 to the x was our function, and we took the derivative of that, we would get 2 to the x ln of 2. So if it's not e, that does come into play, and one of those things that we need to double check and make sure that we understand. Not what I'm looking for. Shoot, sorry. I just want to make sure that if there's any questions that I make sure to answer them. So far I think we're okay. So when we do this and we're getting the derivative, remember we do 2 to the x, so e to the x is e to the x, 2 to the x is 2 to the x, but we still have a ln of whatever our base is, our base value being e for this problem, being 2 for this problem. But ln of e just becomes a 1. So it's a moot point for e to the x, but it is not for any other one. So then our last step is we want to find out what it is for -1. And this is going to be that, which if you oops, what am I doing? I don't need the inverse. Sorry. I need the derivative. If I am taking that, I'm going to get 1 over e to the 1. Because remember, the negative brings it down into the denominator or puts it up in the numerator if it's in the denominator. And actually, we don't even need the 1 because that's redundant as well. So you might see the answer as being just 1 over e. And it probably will give you a -1 here as well. So what we need to remember, though, is this situation. If we have this situation where the limit as h approaches 0, f of a minus h minus f of a all over h is really, they want the derivative at that value. The other one, oh, making me work now. It's x approaches a. We're doing f of x minus f of a over x minus a. I really think this is it too. Same thing, same type of thing. Where this one would have been e to the x minus e to the -1 over x minus a -1, so it'll probably be a +1 there. And then the limit as x approaches -1. The problem with this is in these types, they give you what f of x is. They kind of like really draw out what the a value is as well. So this one's not as tricky to take the derivative of and plug in your value, where this you need to understand that connection between these two problems. So more often times on the AP exam, you're going to see this type over this type, even though they're kind of the same. They're definitely the same idea. They just look different. But the purple one's a little more challenging to make sure that people understand that they're really looking for the derivative at a certain value. And you can't just plug 0 in, because 0 is the h value, not what we're looking for. We're looking for the a value. So that's what makes it a little trickier. And usually why you see this more oftentimes on the AP exam than this one. All right, next problem. Okay, so continuity. So remember, if you have any function, and it doesn't matter what the function is, once we continue, if we want the function to be continuous, wherever this value stops for the top equation, the bottom equation's got to pick it back up at that same spot and then do whatever it's going to do. So the key number here is our x value, which is 3. But we have to make sure that when 3 comes in from the left and 3 leaves from the right, that they're at the same value. So when we look at this, this is where how we work these. So let f be the function defined above. So we got a piecewise function here. And then it says where k is a positive constant. And for what value of k, if any, is f continuous. So when we do this, what we're looking at is we're looking at the left-hand side, k cubed plus x, and we want it to be equal to the right-hand side. Because if they're equal to each other, that means one leaves off where the other one keeps going at a specific x value. Now, that doesn't mean that it has to do it for everyone, but we're looking specifically at that 3 value. Okay, that's going to come into play as well later on. But let's do some algebra out of the way first. So when we have a denominator, we could even put this over 1 and then cross multiply, however you want to solve it. But yeah, I think that that's probably the easiest way, is to just cross multiply this and cross multiply that. So we're going to get 16 equals k cubed plus x times k squared minus x. Wow. What are we going to do? So let's draw a box so that we can multiply our two polynomials together. We're going to do k cubed plus x, and then we're going to do k squared minus x, x squared, and we're going to do row times column. So that's going to be k squared x, that's going to be negative k cubed x, and then this would be k to the 5th power. We add those together. K to the 5th plus k squared x minus k cubed x minus x squared equals still 16 on the other side. What we definitely want to do is get rid of the x's, because now we have two variables and we only want one variable. So let's plug in our 3 value for that x. 3 value and then 3 value. So this is going to give us k to the 5th plus k squared minus k cubed. When we do this, first off, we're going to get that minus 9 over here, so we could add it to the other side, right? So we're going to add 9 to both sides, because it's going to be equal to 16, so that the whole thing's going to equal to 25. So rewrite all of this equal to 25. So we're going to put all of that equal to 25, because we put that 9 down here, we zeroed out the 9, so we added it to both sides, and when we do 16 to that, we get 25. So our problem right now is k to the 5th, and I'm going to put the k cubed next. I should have done that, but we put that 3 in. So then it should be 3k cubed, and then plus 3k squared. Now, here's the cool thing, is that still equals 25. Is we can take the k cubed out of each of these. And if we take k cubed out of, it starts writing like crazy if I do that. If we take k squared out of everything, we're left with k cubed minus 3k plus 3. It's 25. So one of our values is going to be 0, right? Oh, crap. I changed the problem. Sorry. Did not mean to do that. We're still here. So let f be a function where k is a positive constant. So for what values of k, if any, is f continuous? So we have k equals 0. Well, that's not a positive constant. So now we have to look at this right here and see if we can make something of k cubed minus 3k plus 3. K cubed minus 3k plus 3. and see if we can do anything with that. Now, when you look at just factoring in general, I don't know if we can do, that's not a perfect cube. So what I would suggest doing for this problem is graphing it and seeing what the graph looks like. So if that's the case, we're going to, actually, let's just do this. Go to Desmos calculator. We want x cubed minus 3x plus 3. And if we look, the only solution would be that, negative 2.14. Which, if we look, where k is a positive constant. So does it have a positive constant? Unfortunately not. Just a negative one is all we get. So this one would be wouldn't have a solution. So a lot of work, I get it, but that's how we want to define whether it's continuous or not. Take these, set them equal to each other, plug in your x value. We could even plug it in here. I was just trying to show it throughout, but we could have plugged 3 in right off the bat too, if that makes the problem easier. I don't know if it does or it doesn't. Dealing with x's or 3's, it didn't really change much for me, but it might for you. Okay, so let's hit up this one. So we have the limit as x approaches negative 4 of the function x plus 4 over x cubed minus 16. First rule of limits. Plug it in. Plug it in. So the first job that I'm going to do is I'm going to take the limit and I'm going to plug it in. So it looks like I'm going to get 0 on the top. I'm going to do negative 4 cubed minus 16 times the negative 4. And I'm going to get 0 on the bottom because 4 cubed is 64, 16 is 4 squared times another 4. So I'm going to get a negative plus positive. And all this tells me is indeterminate, which means I can't make any assumptions about anything right now. What I need to do, and this would be on a non-calculator one, is we need to start trying to cancel stuff out. So use your algebraic skills at this point. So if we have an x plus 4 on the top, your mission and what you're really trying to work for is an x plus 4 on the bottom so that they cancel out, and then I can come up with an answer. So can we take an x out of both of these? So factor an x out, and when we do that, we're left with x squared minus 16. Now, if that's the case, we can take that x squared minus 16 and break it up. Hopefully you're starting to see this pattern. But the limit as x approaches negative 4, we're going to get x plus 4 on the top. We have an x already. We're going to do x plus 4 and x minus 4 on the bottom. Okay. And hopefully we see that this x plus 4 and this x plus 4 are going to one out. They're not canceling. They're not zeroing. We're oneing them out because anything divided by itself, 5 divided by 5, 20 divided by 20, x divided by x, all comes out to just be a 1. So now what happens is we have the limit as x approaches negative 4. We're going to have a 1 on the top, and we're going to have an x and then an x minus 4 on the bottom. Now, I can guarantee you we're not going to get indeterminate because we have a number here. Now, if we get a 0 under here, that means it's undefined, which is different than indeterminate. It means it doesn't have a solution at this value. Or we can plug it in and actually find what the answer is. So, without further ado, we're going to plug in negative 4 and then we're going to do negative 4 minus 4 inside the parenthesis. So I plugged our x value here and our x value there, so that's where the negative 4 and the negative 4 come into play. So when we do that, we're going to get the limit as x approaches negative 4 to be 1 over negative 4 times negative 8. So then that becomes 1 over 32, which is my answer. This definitely, you would see the non-calculator portion of the AP exam. Oh, sorry. Okay, clean slate. Next problem. Hopefully we see this was just a practice on the quotient rule. Some function divided by the other. If we break it up into u and v, the quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. This would be the derivative function, the quotient rule for this. You can do, and it's up to whatever you're most comfortable with, if you can just do the bottom times the derivative of the top, or if you need to, establish what the top is, x plus 1, take that derivative, which is just going to be a 1, do the same thing with the bottom. Establish what the bottom is, take the derivative of it, and then all we have to do is substitute into this quotient rule. So v is x squared plus 1, u prime is 1, minus u, which is x plus 1, times v prime, which is 2x, and then it's all over v squared. So x squared plus 1 squared. I'm going to leave it like this before I expand it out, because if I get an x squared plus 1 on the top, maybe that would cancel out with one of them, and that's what I'd be left with. So first things first, I've got an x squared plus 1 times 1. That's just going to leave me with my x squared plus 1. Okay, because 1 times this is just going to be that. Minus, now I'm going to get 2x squared plus 2x all over x squared plus 1. Distribute in the negative, so I get negative 2x squared minus 2x. Drop the parentheses on the front one. Now I can start to combine like terms. Make sure it's all over our denominator. And we're going to get, as a final result, negative x squared minus 2x plus 1 over x squared plus 1 squared. So that's what our derivative would look like. If it asks us to plug in a value, then we can plug in a number and find that. But that's, excuse me, what your final solution should look like. The expanding out the denominator isn't going to help us cancel anything, so I don't see that as actually being something we would want to do. And remember, time is definitely not on your side on this test. Whoa. Shadox, thanks for the follow. Appreciate that. That's awesome. So make sure, like, you got a time, so don't waste your time trying to expand that. Look for this solution first. See if there's any connections you can make to this solution or some of your choices. But really, this should probably be your final answer. All right. Next up, we're going tables. Oh yeah. Okay, so I see a table I've got f of x, I've got f prime, I've got g, I got g prime, and they're all at this specific value. So they're not jumping around. We're not trying to substitute stuff in, not really an inverse function. They're all going to be at that value. So what we need to do is look over here, because the table above gives the values of differentiable functions f and g and their derivatives at x equals 1. What they're doing is they're going to give you h of x, and then they're going to expect you to find the derivative of h of x. So what we need to focus on is really what h of x actually is. And when we see this, we have 2f of x plus 3, and we have 1 plus g of x. Now, however you want to work through this is up to you. But before I would start anything, I would look at starting to draw a box. Because I want the easiest way to do this. And I think if you were to have like a polynomial times a polynomial, multiplying it out, the power rule is real easy to work with. So I think this one will show us if we have like a product rule or a quotient rule or something that we need to kind of play a game with, if we multiply it all out. So 2f of x, we have 2f of x times g of x. We have 3g of x, and then we have just a 3. Now this one, when we take the derivative, we don't care. Throw that one out the door. That doesn't, we don't, I mean, if you want, you can put it in, but understand we have 2f of x plus 3g of x. Those are going to be the two easy derivatives. This one is going to be the complex derivative. Think about it. Ask yourself why it's going to be the complex one before I tell you. And then taking the derivative of that just falls off. A constant. Derivative of a constant, 0. So, I'm not going to tell you yet, but keep thinking about it. The derivative. So take the derivative of this. So 2f of x just becomes 2f prime of x. The derivative of f is f prime. Don't overcomplicate this in your life. 3g prime of x. And remember, we talked about that denominator falls off. This just disappears. What is our issue here? And hopefully your brain is saying product rule. So the first times the derivative of the second plus the second times the derivative of the first. We need to take that product rule. Now, once we have this whole long equation, now what they want us to do is find it at a specific value. So what we're going to do is we're going to take h prime and we're going to plug 1 in. So we're going to do 2 times f prime at 1 plus 3 times g prime at 1 plus 2 times f of 1 times g prime at 1 plus g at 1 times 2 f prime at 1. Which I hope it doesn't feel too complicated. I know it looks confusing, but once again, if we just take the derivative piece by piece by piece, this was the challenging one, but you just putting the derivative, put it the derivative, and then we have a product rule. And then when we do this, just plug in what the value is. We know f prime at negative, or f prime at 1 is negative 2. And there's a 2 plus 3 g prime at 1. G prime at 1 is 4 plus 2 times f prime, or f of 1. F of 1 is just 3 times g prime at 1. We're back to 4 plus g at 1 is negative 3. And then there's a 2 times f prime, which is negative 2. And all of these, when we do that, is going to be h prime at 1. So that equals negative 4 that equals positive 12. 12 times 2, that's 24. And then a negative and a negative is going to be a positive. So 6 times 2 is another 12. So I have 24 plus another 20 because the negative 4 takes that away. So 24 plus 20 is 44. So h prime at 1 equals 44. Once again, don't be afraid to use the Twitch stream chat if you need to. If you're in Discord, pop up, unmute yourself, ask a question. I don't want everyone to feel like they have a voice if they need it. Okay. Well, let's keep rocking then. Got, I don't even know what number I'm on, but got some left to go. Oh, number 6, let's say. All right, here. Oh, I definitely wanted to do this. What is the average rate of change? Going back to almost the beginning. F of B minus F of A over B minus A. They want you to take the two endpoints and find the slope between them. So you have to take where you start, where you finish, and find the slope between them. That's all they're looking for. Oh, man. All they're looking for in this problem. So we are going to work with f of 0 and f of 3. When I say, how do I word this properly? If you're worried about which one is going to be A and which one's going to be B, just stick with like left to right. Okay? Just stick with left to right. So A, so my 0 to the 4th power minus 5 times 0. Hopefully we are good to say that f of 0 is 0. And then we're going to do 3 to the 4th power minus 5 times 3. So that's going to be 81, because I'm looking at it as 3 squared and 3 squared. So 3 times 3 is 9, and 3 times 3 is 9. 9 times 9 is 81 minus 15. So f of 3 becomes 71, 66. 66. So that would be 71, 81. Okay. I like it. If everyone else is on board, hopefully I didn't screw that up. If I did, you can fix it. So f of 3 minus f of 0 over 3 take away 0. So when we do that, we're going to do 66 take away 0 over 3 take away 0. And when we do that, when we get 66 over 3, which is 22. And that is the average rate of change. Now, if they were looking for the instantaneous rate of change, we would take the derivative and plug a specific value in. I think kind of what helps out too is that which x do we plug in? Well, if they give you two x's, you're probably not plugging a specific x in. You're really more or less looking for the slope. And this will pop up actually later in the final as well. Ooh, I liked this one. I thought this one was kind of clever. Can I make the graph? How do I don't know if this is going to work. I'm going to try. It's grid visible. Close. Yeah, no. Bummer. Yeah, see, this is what I was trying to do. But if I do that, I can't have it up. Okay. So I'm sorry, no graph. I should have. Ooh, actually, no, this is what we'll do. This. We will steal that. We can. Oh man, I tell you, sometimes I even surprise myself. Look at that. Okay, so now put our axes in. Beautiful X, beautiful Y. We switch problems. I'll go back, I promise. Okay. All right, so the polynomial P of X. We don't know anything about P of X except that it has a relative maximum at -2, 1, 2, 3, 4. So there's a maximum there. When we think about a maximum, it means we're doing something like that, right? Then a relative min at 1, 1. So then we're doing something like that. And then another relative max at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Reminds me of Sesame Street. And no other critical points. How many zeros does P of X have? So first off, let's ask ourselves the question, what do they mean by a zero? When they talk about zeros, they're talking about this. How many times is it going to cross this? Okay. Well, with that being the case, start to think about what's happening. I've got a maximum here, and then it's going to do something, and then it's going to come to a minimum here. So, I mean, it could do a whole lot in between these 2 points, but at the end of the day, they are staying between here and here because this is a maximum, this is a minimum between these two. Same thing with this. This could do, and then it's going to hit here, and that's going to be that. Now, these, if this is a maximum and this is a maximum, there's only one way for this to go. Down. And down. Now, you might ask yourself this question. Well, Schmidt, why do we know that they're going to go down? What if they asymptote out? Or what if, because what do they tell us it is? It's a polynomial. Okay? Polynomial means we have some humps. And Sally the camel has 3 humps. So we actually know that this would be an x to the, or I'm sorry, 2, so that would be, yeah, 1, 2, 3, so it'd be x to the 4th. It'd be a 4th function. And it makes sense because it's an even function. That means they're either both going to go up or they're both going to go down. And the fact that they both end down means that it's negative. So this is actually a negative x to the 4th function with some other stuff at the end of it. But that is essentially what our graph looks like in the rough sketch. But our only question is, we don't really care what it looks like. The question is, how many zeros does it have? And how many does it have? 2. And that's it. Tricky, I know. Okay, I definitely put this one on. This is... Really? What? Did it not? How can it not save? Okay. This down. This is an ever popular AP exam question, which is different than the one that I discussed. We had a, it was a wild problem. It was like this, and we were trying to discuss continuity, and of course it was at 2 was the value that we were looking at, and it made it really tricky, really interesting, and really kind of made you think about what it means to be a limit. I don't want to go into that right now because it was tricky. But this is actually very, very popular problem in AP calculus, is taking something and putting it over the absolute value of the exact same thing. I mean, the two definitely changes a little bit, but when you look at this, what you're going to do and which of the following is true, we even can't even answer this question, but that's not the focus. The focus is there's going to be two different types of solutions to this equation. All right, plug any value in you want, any value, pick one. If we pick 4, okay, 1, 2, 3, 4. If we put 4 in here, 4 minus 1, and then 4 minus 1, and do the absolute value, we're going to get 3 and 3. So at 4, we're going to be up here at 1. And the same thing goes for 5, 6, 7, 8, until we get to a certain value where it's not. That value is at 1, because what happens at 1? We get 0 over 0. So this becomes a graph that looks like that. And then what happens if I plug in 0? If I plug in 0, I get negative 1 over 1. So then this just becomes a negative 1 as my answer. And then the same thing goes, negative 2, 3, 4, 5. We get this going on. Okay? So it's a jump discontinuity at our undefined value right now. And this is what this graph is going to look like almost every single time. Now, is this 2 in front going to change it? Absolutely. It will change it a little bit. And what, let's do it in a different color. Do x minus 2 over 2 x minus 2. What's going to make this 0 over 0? Is when we plug in 2 as our value. So our 2 now is going to be that value that does that back and forth. Now, is it really going to be at 1, Schmidt? That's a good question. So let's plug in 3 and find out. If I do 3, take away 2, and then I do 3, take away 2, and I put a 2 out in front, this becomes a 1, and this becomes a 2, because 2 times 1 is going to be a 2. So really it gets moved down to the 1/2 and the negative 1/2 and shoots it out that direction. So be careful with that. But that number in front isn't going to change. You're still going to have one direction and then the other. If there's a negative out in front of the x, it'll flip-flop them. But this is a very, very, very popular AP type question. You will definitely, I can almost promise you, every year you see a question like this. And what you need to understand is there's just two directions. There's the right direction, left direction, and it's going to be 1 or 1/2 or whatever the number is in front of the absolute value sign. Just kind of some form of this. So just know that, make your tables if you need to, start to think about plug in numbers if you get confused. Your numbers are your friends. Plug them in. Man, I just realized, and I'm sorry about this, that my face on my Twitch stream is covering up half of this. I don't know how I can, I know how to fix it, but I don't know how to fix it. Sorry for that. I'll do better next time. Hopefully it hasn't killed too many things. I don't think I've worked too much over here. I know there's been some, but working as best I can. Okay, so this one. Do you notice how there are two x values? And then there's an h and an h prime. That's going to come into play. So we have h of g of x equals x. What they want us to do is find g prime at 7. This ought to be interesting. We need more information that we don't have. Hold on a sec. I promise you I will explain, but let me work through it first. Times g prime of x equals 1. I need to go g divided by g x. So maybe it's the g of h of, I bet that's what we have to do. Okay, so they're testing your knowledge on inverse functions. Do you remember how inverse functions work and how they're related to each other? Where you can plug one into the other, or you can do the reverse and plug h of x into g as opposed to g into h. So if we know that, then g prime times h prime of x equals 1. And then g prime of h of x equals 1 over h prime of x. And if we are looking for g prime of 7, then that means h of x equals 7, right? If I look at this, h of x equals 7. And what value for x gives me 7? 3. So then that means this needs to be a 3. And then h prime at 3 would be 5. So g prime at 7 equals 1 over 5. All right. Here is the reason that we talked about the earlier one. Do you recognize this? And I don't want to put it all the way around. Hopefully you are saying, oh yeah, that's just the slope. And what did we call that earlier? The average rate of change. So what we have is we've got a graph of a function with f of b being greater than f of a. So that means the y value of the second or the end point here is higher than the one here for all of in between a and b. So a starts here, b starts here. F of b is higher than f of a. The derivative exists for all x except for 0. There's no derivative here. So that's not, no good. How many values of c are there? So how many instantaneous rates of change between a and b does the limit of f of x minus f of c? Remember, look at that. What is that? F of x minus f of c over x minus c as x approaches c. They're once again talking about the derivative at a value. So the instantaneous rate of change, the slope at that point, or the slope of the tangent at that point, sorry. So they want to know when the slope of a tangent at an x value, we'll say x equals c, at some c value that's equal to the rate of change. So what's the rate of change? Well, this is connecting that. How many times do we see this slope as we go through? So when we go through and start to shrink, like, oh, this is not going to be good. But we've got a slope here, slope here, slope here, slope there, slope there, slope there, slope there, slope there, slope there, getting there, right? And then we got a slope down, slope down, slope down. There is no slope here. Then slope there, right? And then down, 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 and then slope there. And then up. So hopefully we can see that there is 3 different instantaneous points between A and B. Does that sound right? Could we have one here as well? Here, here, and here. We'd see all 4 of those. Eventually, when we're running that slope, we're going to find that value where this instantaneous rate turns into that average rate. At some, because it's curving. At some point, it's going to curve to that value, one way or the other, because we're going to start at 0 and we're going to go crazy. So in between 0 and crazy, in between crazy and 0, we're eventually going to come across that slope, either on this side or on this side, on this side or on that side. You're going to get crazy at those points. So hopefully that makes sense. All right. I do believe this is the last one. I can go back to the beginning too, just because I know I started a little early, but I didn't know how many I could get through, and I want to make sure I get through everything. And it's all recorded, so if you want to go back through the Twitch stream and watch some of this, you're welcome to do so. But the function f is given by this function right here. They give us this function. The problem is we have 2 values. We've got a and b that we don't know. Okay? The figure above shows a portion of f. Which of the following could be constants of a and b? Now, if we remember some of our work, what is the limit as x approaches infinity? Hopefully we go back to our function races. And what happens to our function races is they cancel each other out, and we are left with the coefficient of being our answer or our solution to our problem. Well, what is the horizontal asymptote when we go out to infinity? So really we want 3x squared over x squared, because when these 1 each other out, we're left with a 3. So the limit as x approaches infinity is going to be 3. Now, therein lies our first kind of question issue solved. The second part is, what does a vertical asymptote do? Doesn't that tell us where the function is undefined? And how do we get an undefined function? We get a 0 in the denominator. Well, what's in the denominator? X squared plus b is in the denominator. And do we know what x value we're looking at? Well, we're looking at 2. So could we plug 2 in there to be undefined? And 2 squared is 4. Goes 0. And then to solve for b, we would subtract 4 on both sides, and our b value comes out to be -4. And think about this, if we plug 2 into that, 2 squared is 4, and then 4 take away 4 would end up being 0 in the denominator. So, and that undefined value makes it a problem in our picture because it makes it undefined. And this problem specifically creates that asymptote. It could have created a hole, could have created a cusp, it could have created a lot of things, but in this problem specifically, it creates an asymptote. All right, so let's check. I do think that is all, yep, all she wrote. Okay, so what I do want to is make sure and get back to the beginning. Only because I did start a little early. I showed U substitution with this when I did this problem. And I made the U equal to tangent squared x, so that when I take the derivative of that, power rule, so put the 2 out in front, go down by 1, so 2 becomes a 1, and then we times it by the nested function of tangent, so the derivative of tangent. Again, this one hopefully you're starting to memorize by now, but it's secant squared. So derivative, I did that last time too. It's not x, it's what? It's u, so I should be putting the u there. So the derivative of u with respect to u is e to the u times du. So when I do that, let's plug our u back in. So our u is going to go back to our x. Our u value is tangent squared x times du, which is 2 tangent x secant squared x. And I did say this earlier too, if they don't want you to confuse the exponent with the rest of it, so they probably will give you 2 tangent x times secant squared x, then e to the tangent squared x equals f prime of x. All right, so it gives us that. I think that pretty much, yeah, because then I talked about this being a derivative function. So before I go, let's, because you've been such a great audience, I want to this one I want to check. I do want, let me check this one. Yeah, so it's 4. Okay. Yep, because we hit that one, that one, that one, that one. Yeah, so we were good on that. Okay. And what was the other one that I definitely, oh, this bad boy. Let's look at that real quick too. I want to make sure there's no such value. There's no k value. Oh, wait. Okay. If you solve that, I don't know. Let's do this because we did set it up. I'm curious now. So that would have been k cubed, so x cubed plus 3. 3. And then we're doing x squared minus 3. One was plus, one was minus, right? Okay. And then we would minus 16 to the other side. Oh, interesting. So then let's do this. Base squared. And then we have to move the 16 to the other side in that. Interesting. Yeah, that one would definitely be a calculator problem for sure, because they want you to graph that. Oof. Nasty one. Okay, so why don't we, I want to make sure we are on that together. So let's go to the desktop flip chart, and I want to look. Okay. So once we got here, and we plugged it in, and we said that we had x to the 5th so we did x to the 5th minus 3x cubed plus 3x squared minus 9, so that would be minus 25. Get rid of and 2.081. Okay, all right. Oh, so we did it. I just had to set it equal to 0, and instead of setting it equal to 25. Oh, because I didn't set these solutions equal to 25. Makes more sense though. Okay. So yeah, here's what I should have done. Is bring this 16 over to the other side. Make it all one thing. So we're going to do k to the 5th minus 3k cubed plus 3k squared. And then when we subtract 16 from both sides, this is a negative 9, so that makes it a negative 25 equal to 0. Now we can graph this and see where it crosses the x-axis. And where it does is the value that it wanted was that value. Okay, so that's where I should have changed gears. Hopefully that makes sense. All right. Did I show you enough problems? Did I show you enough other problems that maybe you could have, go back in a stream and go, oh man, I wonder about that. Oh, what about, because you can pause and go back and look. Yeah. Anyways, all right. Hope you had a good time. I'm so glad all of you, everyone showed up that did. Hope you got a little something out of it. But study, and be ready. 'Cause you know what's coming. All right. I'm going to end it here. Once again, thanks everybody that came out. I appreciate it. And see you tomorrow.